Hello everyone, I'm Siddharthan. Currently, we are in the seventh module of our hands-on machine learning course, and this seventh module is all about building machine learning models from scratch. The fifth model that we are currently working on is a K-Nearest Neighbor Classifier, and in my previous videos, I have explained you what is the intuition and math behind a KNN classifier model and how we can calculate the Euclidean distance and Manhattan distance in Python. So using all these concepts, we will try to build a KNN classifier model from scratch in Python, and this will be the agenda for today's video. So before getting started with this topic, I would like to tell you about One Neuron. One Neuron is a subscription-based platform where you can learn from almost 100 courses. It is just like an OTT platform for education, and as I've told you, you have an yearly subscription price of 7080 INR including GST, and for this price you will get 1 year access for all the courses and services that are available in One Neuron platform. And the important thing that I wanted to tell you is that there is an interesting offer that if you get this subscription before 15th January 2022, you will get lifetime access for all the courses and services provided in One Neuron. Say for example, you are getting the subscription which is 7080, and if you are paying this after 16th January, so in that case you will get access for only 1 year. Whereas if you get the subscription before this date, so you will get all the access for your entire lifetime. So you can just go to the site and check all the courses that are available. So I have also given the link in the description. If you use that link, you will get 5% discount of this entire amount. Okay, so if you go to that link, it will take you to this site called as Neuron, and you can see this buy now option, and below that we have all the courses listed. So these are all the courses that are available. So we have courses like digital marketing, R programming, Linux. There are also courses on several data visualization tools like Tableau and Power BI and so on. So you can see this. There are also cloud courses like Google Cloud Platform, Kubernetes, and all. And there is also full stack data science course, and also this full stack data science course is the recorded course of the previous batch. So if you already are familiar with iNeuron, so they are conducting this live classes for full stack data science, but that is separate. Okay, whereas in this One Neuron platform, you will get the recorded course of the previous batch. So we also have courses on big data and other courses. So there are almost 100 courses from which you can learn from, and you can go to this buy now option. So if you use the link that is provided in the description, you will get a 5% discount. So the total amount payable will be 6,726 Indian rupees. Okay, so once you sign up, this is how your dashboard will looks like. Okay, so before checking out, you need to create your account with email address and other details. So after getting the subscription, you can see this go to One Neuron option where you can get access for all the courses that is available. So you can go to any course and start learning. And the other important features are, so you can raise your demand. Okay, so you can go to this raise your demand session, and you can request for a course. Let's say that you want to learn a different course which is not available in this platform, so you can raise your demand here, and if the demand is high, they will create a separate course on that particular topic within 60 days. Okay, so there are also other offers like you can ask for separate module in a course, and a separate explanation for a topic, and there is also doubt clearing sessions and so on. So there is a resume discussion, mock interviews, and so on. So you can also get details on how you can get internships with iNeuron and such things. So you can raise your demand here, and there is also live session for a doubt clearing. So you can click this check now option here. So it will give you the schedule for doubt clearing session. So from 5th January 2022, this is the schedule. So on Monday 12 p.m. to 3 p.m. there will be doubt session clearing on development, and say Monday 3 p.m. to 6:30 p.m. there will be doubt clearing session on data science and so on. So this is the schedule for doubt clearing session, and all these are live. So this is about One Neuron platform. See whether this is useful for you. And in my personal opinion, it's a great deal because you get this access for courses and services for your entire lifetime if you could sign up before 15th January. So with that being said, let's get started with our KNN code. Okay, so you can see here, so this is my Euclidean distance formula, and this is my Manhattan distance formula, right? So we have discussed about this in our previous video. And in the next step, we are importing the dependencies. So we need two libraries here. One is NumPy library and the statistics library. So these are all the libraries that we need. So I'll just connect my system and run this particular code so that our library gets imported. And now we are going to build our K-Nearest Neighbors Classifier. So I'll just create a text here. So we are going to create a class, and we are going to name this class as, so class KNN classifier. Okay, so let's try to understand what is meant by this class. So most of you might know what is this class. So if you're not familiar with this, so it is creating a template for an object. So you can consider this KNN classifier as an object, and we are creating a template for this particular object. So this is like, let's say that we want to build a car. So this car will be our object, and in order to build this car, we need a template, we need a blueprint in order to create this. So this class is that blueprint, and the object that we are creating is KNN classifier. So the reason we are creating this class is that we don't want to write the code for KNN classifier every time we want to use it. So this is just like a ready-made object so that we can use it every time we want. So we will be creating a class and we will name this as KNN classifier, and you should mention this parenthesis, and we need to give some important functions within this class. So the functions that we will be needing are init function. So init stands for initiation, and the use of this init function is to initiate the parameters that is required for this KNN classifier. And the second function that we are going to use is, so first of all, I'll write all the functions. So the second function will be get distance measure. So get distance metric. So get distance metric. So in this function, we will create a few lines of code from which we can calculate the Euclidean distance and Manhattan distance between the 2 points. And the third function that we will be creating is getting nearest neighbors. So define nearest neighbors. So this will be our third function, and the final function will be our predict function. So define predict. Okay, so these are all the functions that we need. So first, initiation functions for initiating the parameters, and get distance metric. So it is useful in order to find the Euclidean distance or Manhattan distance between the 2 points, and based on this distance measure, we will try to find which data points are the nearest neighbors to our test data. And this predict function is used, like when you give a test data, it will try to predict to which class does that particular test data belong. So these are all the 4 functions that we need, and we need to give the parameter called as self. So this is the inbuilt parameter that we need to give for all the functions that we are creating for this KNN classifier. So this will be the first parameter for all the functions. Okay, so this is our first parameter, and the important parameter that we need for initiation is distance metric. Okay, so while you are calling this KNN classifier, we will mention whether we want to use Euclidean distance or Manhattan distance as our metric. So we will use both of these things, and the user can select whether that particular user wants to carry out this KNN classifier using a Euclidean distance, or they want Manhattan distance, and so on. So that will be our important parameter. And for initiating this, we need to mention self dot distance metric is equal to distance metric. So the user will mention whether it is Euclidean or Manhattan. Okay, so the reason for using the self is that, let's say that we have completed this KNN classifier code. Okay, so what we will be doing is we will create a variable called as classifier, and we will load the instance of this KNN classifier. So I'll just copy this KNN classifier. So after completing this, we will do this. So KNN classifier, and we will mention this parenthesis. So this is just like loading the KNN classifier to this particular instance, and this self take the value of this instance. So in this case, the instance is classifier, and the self will take the value called as classifier. So this is how this self parameter works, and it is also useful if you want to use a function within this class. Let's say that we want to call this get distance metric function within this nearest neighbor function. So in that case, we will be also using self. So you will understand all those things while we are writing the code, so you don't need to worry about this much. So the first step is mentioning the parameter, which is get distance metric. Okay, so I'll just give you a quick recap on how this KNN classifier works. So let's say that we have a data set, and this data set contains 2 types of data. So let's say that in this case, the green color points represents one kind of data, and blue color point represents another kind of data. And we have a new test data, so which is represented in this red color. So when we use a KNN classifier model, it will take this new data point, and it will try to find the distance between this red color data point and all the other data point. So once it finds the distance, it will try to find which data points lies close to each other. In other words, it will try to find the data points which has the minimum Euclidean distance or Manhattan distance between them. So now you will get the nearest neighbors, and based on the nearest neighbors, it will try to see whether the green color data point is maximum or the blue color data point is maximum. So in this case, we have 3 green color data points and 2 blue color data points, right? So it will say that this red color point belongs to this class of data which is represented in green color, and this number 5 is we have to give that number as k is equal to 5 or k is equal to 3 and so on. So if you give k is equal to 5, it will take 5 nearest neighbor. If you give k is equal to 7, it will take 7 nearest neighbors and so on. In order to find the distance, we can use Euclidean distance or Manhattan distance. So there are also other kind of distance we can use. So in this case, we will be using only the 2 distance, and this is how we are going to build our KNN classifier, and this will be pretty different from the other models that we have created, say logistic regression and linear regression and so on, because in this case we won't be using a fit function. So we will be just using all these functions, but we don't need this fit function because we don't need to fit our data to any model. So hence this KNN classifier is also called as a lazy model. Okay, so that is another thing that you can remember. So I'll just make a text here as this is for initiating the parameters. So here we are just initiating one parameter, which is distance metric, and the second function that we are working on is get distance metric, and the use of this particular function is getting the distance measured, or I'll just mention this as getting the distance metric. Okay, so now we need to build the code for this Euclidean distance and Manhattan distance, which we have already seen in the previous video. Okay, so the parameters that goes within this get distance metric are self comma training data. So I'll mention this as training data point and test data point. Okay, so what happens is when we can give 2 values for this get distance metric. So you can mention 2 points. So let's say that we have the code. Okay, so in this case we want to find the distance between the 2 data points. So the 2 data points that we want to find the distance are this one and the red color distance. So we will try to find the distance between them. Okay, so these 2 points. So you need to give the value for each of these 2 points, and that is what we will give for this particular function, which is get distance metric. Okay, so one is the training data point. So in this case it is represented as green color, and the test data point, the second value, is nothing but the one that is mentioned in the red color. So these are the 2 data points that we need to give. And now we are going to create a if statement. So if statement, we need this if statement because we need to decide whether we want to use Euclidean distance or Manhattan distance. So I'll create this if statement, and the condition for this if distance will be, if statement will be self dot distance metric, and if this is equal to Euclidean, in that case we want to use the formula that is mentioned here, which is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Whereas if this distance metric, if it has a value called as Manhattan, then in that case we will be using this particular formula. So the user, while they are calling this KNN classifier, they have to mention that KNN classifier, and within this parenthesis, so they will mention that distance metric is equal to, so they can say whether it can be equal to Euclidean or Manhattan. Okay, so that is up to the user. So they can use this, or they can also use Manhattan. So this is what we are building in our if condition. So we will be having 2 distance metric, and we will be using either Euclidean or Manhattan. So now we will be writing the code in order to incorporate these 2 formulas within this get distance metric. So self dot distance metric, if it is equal to Euclidean, then in that case, so this is the code for finding the Euclidean distance, which is distance is equal to 0. And we will be creating a for loop to easily get this Euclidean distance, which is for I in range length of training data point minus 1. Okay, so I'll explain you why we are doing this. I'll just complete this code, and within this for loop we need to mention distance is equal to distance plus training data point, and the index should be I, minus test data point. Again the index should be I, and this should be squared. And finally, we can take the square root of this, which is our Euclidean distance, which is equal to np dot square root. So we have already discussed about this in our previous video, as I've told you. So np dot square root of dist. And finally, we can return Euclidean distance. So let's try to understand what we are doing in this particular part of code. Okay, so first, when the user mentions that they want to use Euclidean distance measure, so this will be the code that runs. So first we are initiating the variable, and we are giving the value as 0, and then we are running a for loop. So this for loop runs the number of times that is equal to the total number of features that is present in the dataset minus 1. So let's say that we have a sample dataset. Okay, so let's consider the diabetes prediction dataset. So that dataset contains several features, and the last column will be the target column. So it will contain the values either 1 or 0, where 1 represents people with diabetes and 0 represents people without diabetes. So while we are trying to find this distance, we should not include the target column, which is either 1 or 0. So we should include all the other features. So we shouldn't consider the last feature. So that's why we are subtracting minus 1. So we should take all the features except the target column. So that many number of times the for loop should run, and this is just nothing but, so this line of code is nothing but, which is represented here. So x2 minus x1 whole square plus y2 minus y1 whole square. So in this case, it can represent that the data point has only two features. So the first feature is x and the second feature is y. And x1 represents the feature of first data point, and the x2 represents the feature of second data point. Similarly, y1 represents the feature of first data point, again y2 represents the feature of second data points, and so on. Whereas in real life, we will have multiple features. So there can be 10 features or 20 features and so on. So therefore, in order to generalize this, we are creating this for loop where we can find this distance for any number of features that we want. So if you want a clear understanding or a deeper explanation on how this particular thing works, you need to watch the video on how to calculate Euclidean and Manhattan distance, and I'll give the link for that video in the description as well. So we are finding the Euclidean distance. So once we find this part, we need to take the square root of it. So you can see that we have a square root here, and that's why we are using this np dot square root. So NumPy library has a function called a square root, which helps us to give which helps us to find the square root of a particular value. So this will be our Euclidean distance, and we are returning the Euclidean distance. So this is the first part of the code, and now let's consider the other condition. So here we'll be using a else if condition, which is represented as elif, and in this case, if the user says that he wants a distance metric as Manhattan. Okay, so I'll copy and paste it here. If the distance metric is Manhattan, then we need to change the formula. So in that case, the formula, it's almost pretty similar. So I'll write this as distance is equal to 0, and for I in range, so most of the things will remain the same. So for I in range, length of, so it will be the same thing here, and the formula for Manhattan distance is that we have to separate x1 from x2 and y1 from y2, and we have to take modulus of each of this difference. Okay, so let's try to write the code for that. So distance is equal to distance plus absolute value of training data point. So I'll just mention this. So yeah, this is the term, training data point minus test data point. Okay, and finally we can create the variable called as Manhattan distance, which is equal to dist, and we can return the Manhattan distance. Okay, so we are creating two conditions here. So the first condition is, if the user mentions that they want a Euclidean distance as the distance metric, then we want to use this particular part of our code where we have built this formula for the Euclidean distance, which is represented by square root of x2 minus x1 whole square plus y2 minus y1 whole square. So if there are three features in both of these data points, then there will be another term called as z2 minus z1 whole square, and so on. So this is how this works. So the first time this for loop runs. So x2 minus x1 will be subtracted, and that part will be squared. And the second time this for loop runs, so y2 will be subtracted by y1, and so on. So this happens when we run this for loop, and the same goes for the Manhattan distances, as well. So the only difference is that we don't have squared here, and we don't have to take square root and so on. So only the difference is that we have to take the absolute value. So absolute value is nothing but taking modulus of that particular term. So this is what represented in this particular formula. So this function, get distance function, when you give the training data and the test data point, it will try to find the distance between each of those data. Okay, so this is what happens when we run this. And now let's what we will be doing is, based on this distance measure, we need to find which data points are the nearest neighbor to our test data. So in this case, we have seen that there are 5 data points, right, which are closer to this red color data point. So we need to find this nearest neighbors, like the distance should be very minimum. So nearest neighbor, in the sense, the distance between the 2 points should be minimum, and that's what we'll be doing in this nearest neighbor function. So I'll just make a comment here as getting the nearest neighbors. Okay, so for this we will be creating a list called as a distance list, where we will be storing all the data points and the corresponding distance between the test data. So we are creating an empty list here, and I'm going to create a for loop called as training data in xtrain. And the parameters that we need to give to this nearest neighbors are xtrain and our test data and the k value. Okay, so here test data is my red color data point. So you can see here, so my test data is my red color data point, and the x train that is mentioned here is all the other data points. So all the training data points which are represented in blue and green color. So we need to give all this data, and we also mention what is the k value. So k value represents how many nearest neighbors from which you want to choose from. If the nearest neighbor is k is equal to 5, then your model will try to find 5 nearest neighbors. If the nearest neighbor value is 3, it will try to find 3 nearest neighbors, and so on. So this nearest neighbor function should take all these parameters, and we won't be using this particular function outside this class. Okay, so we won't be using this, but we will be using this nearest neighbor function within this predict function. So we'll be using this predict function alone while we are implementing this KNN. Okay, and this nearest neighbor function will be used within this predict function. Okay, so the parameters that we need here are xtrain, which is my entire training data, and test data is my individual test data, and k is my nearest neighbor count. So we are creating a distance list where we will try to find the distance between the test data point and all the other data points individually. Okay, so after that we are storing that in this particular list, and I'm creating a for loop where for training data in xtrain, so I want to find the distance. So distance is equal to, so here we will be using the get distance function that we did. So get distance metric. So I'll copy this and paste it here. So self dot get distance metric, and the parameters are training data and test data. Okay, and then we need to append this list. So I'll explain you what we are doing here. So distance list dot append training data and distance. Okay, so these are all the two things that we need. So I'll explain you what we are doing here. So we have our xtrain here, right? So xtrain is nothing but all my data except this test data, which is represented in red color. So I'm taking all this blue color data points and green color data points. So each time this for loop runs, I will take one training data. So the first time this training data runs, let's say that we are taking this data point alone, and we will try to find the distance between this green, so this blue color data. So we will try to find the distance between this blue color data point and the red color data point. So we will try to find this distance, and this will happen when we run the for loop for the first time. And the second time the for loop runs, we will take this data and we will try to find the distance between these two data points. So this will be carried out to find the distance between all the training data that we have. Okay, so that is what we are doing in this particular for loop. So I'm having this X train and I'm taking one training data from this X train each time this for loop runs. Okay, and I'm trying to find the distance between this training data and the test data that we have. The test data is represented in the red color in this particular picture, so you can correspondingly remember the code based on this particular picture that is represented here. So we are trying to find the distance between the two, which is each training data and my test data, and I can find this distance using my get distance metric, which I have already created. So you can see here define get distance metric, and we can use this in order to find whether Euclidean or Manhattan distance. So you can use either one of those distances, and that's what is done in this particular line of code. So we are creating a variable called as distance, and we are calling the function get distance metric, and we are passing the two data points. So when I run this particular code, I will get a distance metric. So what is the distance between the two data points, and that will be stored in this variable called as distance. Now I'm calling this distance list which I have already created. So you can see the list that we have created, which is an empty list, and we are storing all the values inside this list. So you can use this append function in order to add values to this list, and the values that we are adding are two set of values. One is the training data value and the corresponding distance. So what happens is so we have these data points, right? So the first time the for loop runs, we will try to find the distance between this point and this red color data point. So in my distance list, in that list, this data point will be stored, and the corresponding distance between this data point and this red color data point will be stored. And the second time, this distance will be found, and the value for this data point along with the distance between them will be stored. So this is what happens when we run this second line, which is distance list dot append training data and distance. So we need to do this because we need to sort this list based on this distance. So like as I've told you, we will try to find the nearest neighbor. So nearest neighbor is nothing but the data points that lie closer to this red color circle, right? So we will find that by sorting the list by minimum distance to maximum distance, and that's why we are creating this list. So this will be the second part of the code, and now I'm going to create another list called as neighbors. So neighbors is equal to again an empty list, and now again I'm creating a for loop which is for j in range of k. So k is mentioning how many nearest neighbors that we want. So it can be 3 or 5 or 7. So it is the number of neighbors, and for j in range of k, neighbors list dot append distance list j of 0. Okay, so let's try to understand what we are doing here. So I want to get this neighbors. So get the neighbors in the sense. So now let's say that we have found the distance between the test data and all the other training data that we have, and now we need to find which data points lies closer to this red color data, right? So we need to sort them. So that's why we are creating this neighbors list, and I'm taking the first value, which is my training data. So I'm taking all the values, and now we need to sort that. So I think I missed one part of code here. So we need to sort the data before finding the neighbors. So I'll just come out of this for loop, and here we can write that. Okay, so I'll just remove this. So there is an error here, so we need to come to this particular part later. So once we find the distance between the training data and the test data individually, so we need to sort this list. So distance list dot sort, and for this we are going to use the lambda function, which is key is equal to lambda and x is equal to x of 1. Okay, so let's try to understand what we are doing in this particular line of code. So this list called as distance list will contain the training data and the corresponding distance of that training data with the test data, right? So let's say that totally we have about 20 data points in our test data, and 20 data points in our training data, which are represented in blue and green color, and one test data. So this list will contain 20 different values, which so the first value will be the value of this data point and the distance between them, and I want to sort this list based on the distance. So I want to sort this based on the distance that I have created and not based on this training data, and that's why we are doing this. So I'm going to take this list and I'm going to sort this, and using this lambda function I'm mentioning that x is to x of 1. So here x is nothing but my list, and in this list I'm taking the index value 1. So in the index value 1 is nothing but my distance. So if you mention x of 0, that means the first element that we have. So the first element is nothing but our training data, and the second element, which is represented by the index 1, is our distance. Okay, so I want to sort this distance list based on the distance value. So I'm using this x is to x of 1. Okay, so that's the reason. So let's say that we have interchanged it. Let's say that we have this training data behind this distance. So in that case, what we'll be doing is, so we want to sort the array based on this distance. So in that case, we will mention x of 1. So which means I want to sort this list based on the first element. So here the first element is distance. So that is how this particular code works. So I'll just change this one. So we have created a distance list which contains training data and the corresponding distance, and now I'm sorting this distance based on their distance value. So now I will get a list which contains number of values in ascending order. Okay, so the ascending order of the distance value. So that is done by this particular line of code, and now we can get the corresponding neighbors. So this part of the code will be used in order to find these 5 values. So you can see here that we have mentioned the k is equal to 5, right? So you can see that, so we have mentioned k is equal to 5. So the model has to find 5 neighbors to this test data. So it will try to find these 5 points. So how it will try to find these points is by finding which data points has the minimum distance value. So that will be our next part of code. So neighbors list. So let's create this as neighbors list, and again we will be creating an empty list here for j in range k neighbors list dot append. So it's okay if you don't understand few things. So once I complete the code, I'll give you a clear explanation on each things, and it will make better sense at that time. Okay, so you don't need to worry much about it. So neighbors list dot append distance list j of 0. Okay, and finally we can return this neighbors list. So this will be our next part of code. So let's try to understand this. So once we run this line of code, our list will be sorted based on the distance value. Now I'm creating an empty list called as neighbor list, and I'm creating a for loop. Now I want to find k number of nearest neighbors. Let's say that we want to find 5 nearest neighbors. So in that case, this k will take the value as 5. If we want 7 nearest neighbor, this k will take the value as 7, and the for loop will run 7 number of times, and so on. So let's have the general value as k. So if the k value is 5, so the for loop runs 5 times, and it will take the first 5 values from this distance list. So that's what we are doing here, and we are taking this neighbor list, we are appending only the first value, training data value. So once we sort the list, we don't want this distance value. So the distance value is needed only to sort the data. So once we sort the data, we need to find which data points lies close to each other. So that's why we need only the first value. Okay, so the first value is represented by the index 0, so which is nothing but my distance list training data. So the training data value in my distance list list that we have created. Okay, so first we are creating this nearest neighbor function where we are giving xtrain and test data and the k value, where xtrain is my all the training data, and the xtest that is represented here is my red color data point that is given here. And once we run this function, so this function will create an empty list, and we will try to find the distance between the test data point and all the other training data individually. So this is very important. So we will take one data point at a time, and we will try to find the distance between that data point and the test data, which is represented in red color here. Okay, and that particular distance value will be stored in this distance list along with the data point value. So let's say that we have the diabetes data set. I'll see whether I have any data set here. So so I'll just search for this. I think I have this data set, which is diabetes.csv. Okay. So, just a second. Let this find this diabetes.csv. Okay. So I'll copy this. Now I'll explain you what happens. So you can see here. So this is how our data set looks like. So this is my target column, and these are all the other features. So when I run this particular line of code, so we have this distance list dot append training data comma distance, right? So now what happens is that the model will try to find the distance between the data point and the test data, and it will store the training data and the distance. So what happens is, let's say that the model tries to find the distance between the first data point. So this is my training data, so it will try to find the distance between this particular data point and my test data. So once it finds the distance, all these values will be stored in the variable called as training data, and the distance will be stored as well. So this is what is represented. So the training data represent all my features. So you can see here, so this is my let's say that we have this fourth data point, and we also find the distance between the fourth data point and my test data. So all these features will be stored as my first element. So you can see this particular list. So this contains two elements. So the first element is training data, and the second element is the distance. So this all these values will be stored as my first value, and the distance will be stored as the second element, and so on. So once we find this, we need to sort this list based on the distance that we have calculated, and for that we are using this lambda function. So once we sort this array based on the ascending order, so if two data points as minimum distance, then it means that they are very close to each other or they are related. So that's what we are doing here. So once we sort this list, we are creating another empty list, and we are calling this empty list as neighbor list, and we are creating a different for loop here. So this for loop is to find which data points are close to each other. So you can see this data point. So now let's say that so this particular data points contains about 700 values. Let's say that it contains about 700 values. So the model will try to find the distance between the test data and other 700 data points, and it will try to order it in the ascending order, and it will try to find the first 5 values. So that is represented by this particular line of code. So if k is equal to 5, it runs 5 times. If k is equal to 3, it will run 3 times in order to find 3 nearest neighbors, and so on. And finally we will return the list. So now when we run this nearest neighbors, we will get a list which tells us that these 5 data points are close to each other. So I'll tell you what happens up to this point. So when we run the nearest neighbor, the model will tell us that these 5 data points. So just a second. So these 5 data points, so this is my first data, this is my second data, and third data, fourth and fifth. So these 5 data points lie close to my red color data point, and these are my nearest neighbor. So we have only one more thing to do. So once we find this nearest neighbor, we need to find whether green color data points as the majority or blue color data points as the majority. So in this case, we can see that green as the majority, right? Because we have 3 data points here, whereas 2 data points belong to blue color. So we need to find which is the majority here. So that will be the next part of the code once we find this nearest neighbor. So now we have found this nearest neighbors using this for loop that we have run here. Now we need to find what is the class that is majority, okay, whether it is green or blue, if you consider this particular example. So if you consider this diabetes example, so once we find the nearest neighbor, let's say that we are finding 5 nearest neighbors, so we need to find whether person with diabetes is more or a person without diabetes is more. So we need to check whether the class 1 as the majority or 0 as the majority in the nearest neighbors that we have found. So that will be done in the predict function. Okay, so this will be our last part of code. So this predict function is used in order to predict the class of new data point. Okay, so this will be our next part of code, and we need to mention the parameters self comma xtrain test data and k. Okay, so as I've told you, we won't be calling this nearest neighbor function, so we'll be using only this predict function outside of this k nearest neighbor classifier. Okay, so we need to provide these parameters xtrain test data and k. So we need to mention what is the k value, whether the k value is 3 or 5 or 7 while we are calling this predict function. So what we'll be doing is, so let's say that we have this classifier is equal to KNN classifier, distance metric is equal to Euclidean. Let's say that we have completed this code. So once we train our model, what we'll be doing is we will say that classifier dot predict. So as I've told you, we don't need any fit function in this case. So classifier dot predict. So we have 3 parameters here. One is xtrain, second is test data, and the k is third value is k. So let's say that my xtrain is represented by my x, and test data is represented by x test, and the third parameter is k. So I'll mention k is equal to maybe 5. So this classifier model will try to find 5 nearest neighbor in the case. So this is how we can give the parameters for this predict function. So the first value correspond to this x train. So x is my x train and x test is my test data, and k value is equal to 5. So this is how we can give the parameters. So I'll just remove this. So let's complete the last part of the code now. So neighbors is equal to self dot nearest neighbors. So we are calling this function now. So nearest neighbors, and we need to mention the three points which are extrain, test data, and k. So I'll explain you what we are doing. Just wait a second. So extrain, test data, and k for data in neighbors, label is equal to a list, and finally we can mention label dot append data minus 1. So I'll explain you after completing this. So predicted class, so this is where we will find the final class, which is predicted class is equal to statistics. So statistics is the library that we have imported. Okay, so statistics dot mode, so mode of label, and finally we can return the predicted class. Okay, so this is our final code. So let's see what we are trying to do here. So we are calling this predict function. So the user can call this function alone. So like this function is required for us while we are running this KNN classifier. So when I call this predict function, I have to give my training data, my test data, and my k value. So if you consider this example, so the first parameter, which is my x train, will be all the green values and the blue values. So this is my training data, and I will give my test data, which is represented in red color, and yeah, this single data point, and then I'll finally give my k value, which is k is equal to 5, and so on. So these are all the three things that we need to mention while we are calling this predict function. Okay, and when I call this nearest neighbor function, so you can see, so this is the nearest neighbor function which we have created, right? And the purpose of this function is to return a list. So if you see this entire function, so the purpose is to return a list which contains all the nearest neighbors. So if you understand with this particular image, so when you run that nearest neighbor, you will get all these 5 data points. So these two blue color data points and the three green color data points, so these are all the final result that we get when we run this nearest neighbors, and that will be stored in this list called as neighbors list. So once we have that, we will store that particular neighbors list in the variable called as neighbor, and now we need to find what is the majority of the label that has appeared. In other words, we will try to see whether green color data points appeared the most or the blue color data points appear the most. So if you consider this diabetes data, once we find this nearest neighbor, we will see whether 1 has appeared most of the times, or 0 appeared most of the times. So where 1 represents people with diabetes and 0 represents people without diabetes. Okay, so these are the labels that we have, and need to find which labels appears the most of the time. So if 1 appears 3 times out of the 5 times, then we can say that the test data belongs to the category 1. If 0 appears let's say 4 times out of 5 times, then we can say that the test data belongs to the label called as 0. So this is what we are doing here. So we are trying to find which label as the majority here. Okay, so that is the purpose for this. So for data in neighbors, so this neighbors list will contain 5 data points now. So all these 5 data points are the nearest neighbor to my test data, and I will take each data point when I run this for loop. So the first time this for loop runs, so let's say that we have this 5 data point, right? So when the first time the for loop runs, it will take this value and it will try to find what is the label here. So let's say that in this case the label is blue color, so it will return the value as blue. So the second time it runs, it will take this value, again the label will be blue. So in this case, the third time it runs, the label will be green, and the fourth time also green, fifth time is also green. So we need to find which is the majority. So we are taking each data point. So when I mentioned for data in neighbors, so I have a neighbors list which contains 5 data points, and each time this for loop runs, I am taking only 1 data points, and I'm trying to find the label. So here we are creating an empty list called as label. Okay, so label is equal to this empty list, and we are appending a particular value. So data of -1. So -1 basically represents the last column value. So in this case, we know that the target column is the last column value, right? So it will take this value. So when I mention this data -2, it will take this particular value, or -3 this value. When I represent -1, it will be the last column value. So we know that the labels or targets are present in the last column, right? So that's why we are mentioning data of -1. So when you run this particular line of code, it will take each data point and it will try to find what is the label of that particular data point. So this is a very important thing, because whenever you are using this particular KNN classifier code, the target should be in the last column. So it is very important. So if you have this target column in the first column, then this code won't work, because we are assuming that label is in the last column, and that's why we are mentioning -1. So hence it is always a good practice to have the target column as our last column. So here the target is nothing but the outcome, whether the person is diabetic or not. So we are taking this last column and checking all the label values. So when I run this for loop, let's say that we are finding 5 nearest neighbor. Now this label will contain 5 values. So this 5 values will be either 1 or 0. So when I run this statistics.mode, so we know that in mode basically represents the value which is repeated the most number of times. So we know that we have three central tendency measures like mean, median, and mode, where mean is my average value, median is my central value, and mode is the most repeated values. So I'm taking this label list and I'm trying to find the mode. So mode is the most repeated values. So let's say that this label contains three 1 values and 2 0 values. In that case the mode will be 1, because 1 is the most repeated times. If let's say that this particular list contains 4 0 values and only one value, in that case the mode will be 0. So this is how we are trying to find which will be the majority class. If you understand it with this particular example, so the final code will tell you that there are 2 blues and 3 greens, and when you try to find the mode of this, the final answer will be green, because green is the most repeated value, and we are storing that particular final output in our variable called as predicted class. So your predicted class will give you the variable as either 1 or 0. So this is our entire code, and I'll just give you a quick recap of what we have done in this entire process, and now you will understand completely what are all the processes that are going here. Okay. So first we are creating a class called as KNN classifier, and the 4 functions that we have are init function, get distance metric function, nearest neighbor function, and finally predict function. Okay, so let's try to understand this in the reverse order, so it will make more sense. So we have this predict function here, right? So the user will load this KNN classifier to an instance called as classifier or model or anything. So once they load this, they will give the distance measure as either Euclidean or Manhattan. Okay, and now what they will do is they will call the predict function. So it will be like classifier, as I have told you, classifier.predict my training data. Let's say that training data is X and test data is X test, and the final K values, let's say 5. So this is how the user will call the function. Okay. So once we call this, what happens, we have a variable called as neighbors, and now we need to find the nearest neighbors. So now it will go to this function called as nearest neighbor, where the final output will be finding the nearest neighbors list. So once this function has done function has completed its entire process, we will get a list of values which are the nearest neighbors to my test data points. So if you look at this, we are calling another function called as get distance metric. So when this line runs within this function, it will go to my top function, which is a define get distance metric. Here we have 2 parameters or 2 conditions. One is Euclidean distance and the another one is Manhattan distance. When the user mention Euclidean, in that case this if statement will be true, right? So self of distance metric is equal to Euclidean, so this will be true and this part will be run. So this part will run, so this else if condition won't run, so only one condition will run. So like in Python, like if and else if both won't run, in any case only one of the conditions will run. Okay, so if the user mention the distance metric as Manhattan, so this if statement will be false, and this else if statement will be true, and this particular part of the code will run, and we will be using Manhattan distance as a distance metric. So what we are basically doing here is, so we are creating this KNN classifier as a class. So this KNN classifier will be my object, and we are initiating the basic parameter. So the basic parameter in this case is distance metric, so it can take only 2 values. It can take either Euclidean distance or it can take Manhattan distance as my value. You can also include other else if statements where you can include other distance metric like Hamming distance or anything like that. So you can also include other distance using their formulas with another else if condition. So in this case we are considering only 2 cases, which is Euclidean or Manhattan, and the second function is creating this get distance function. So when I give 2 data points, point, so training data and test data point, it will try to find the distance between them. So this is the formula for finding the Euclidean distance, and this is the formula for finding the Manhattan distance. So we'll be doing only one of the two things and not both of them. Okay, so after that we'll be finding the nearest neighbors. So based on this list, so we will try to sort this array, so sort this list based on the distance value. So the final result is that you will have a list containing ascending order of the nearest neighbors based on their distance between the test data points, and finally we are creating this neighbors list. So once we have this predict function will run in order to find what is the majority of the class. So class in the sense label. So in this case I am not using the word class because it is already used here. So there is an inbuilt function in Python called as class, so we cannot use class here. So you can see here, so you cannot use class here, and that's why I'm using the term label. So you can use anything, a target or label or anything. So the final part of the code will be to find which label has repeated most number of the times, and for that purpose we'll be using this mode function, and finally we are returning this predicted class, which is either 1 or 0 or whatever it is. Okay, so this is how this particular KNN works, and this is pretty different from the other models that we are worked on. So I've made this completely based on the topics that we have discussed. So there is it's like it's not complicated with fit function and other things and so on. So we are not using any optimizations like gradient descents or anything like that. So this is how you can build the K nearest neighbor classifier from scratch in Python, and I hope that you understand this completely. So if you have any doubts, please mention in the comments, and in the upcoming video I'll explain you how you can implement this code, how you can implement this KNN classifier using this diabetes data. Okay, so we will be also discussing this. So if you don't get a few things properly, so you will understand how this KNN classifier works with an example. Okay, so that's it from my side, and see you in the next upload, and thanks for watching.